Is it screen visible to us? Visible?
Yes, sir.
Okay. So the next point is reduction of order of homogeneous equation. Okay, suppose we have found one solution of L of y which is equal to 0, then using the variation constant method, we can reduce L of y is equal to 0 into linear differential equation of order n and obtain the second solution of the differential equation. Okay, so by using variation constant method, we can find phi 1, and that using the phi 1, we can obtain the second solution of the differential equation. Okay, for this one, we have one theorem. Look at this theorem. What is this statement of this theorem? If phi 1 of x, okay, is the solution of L of y is equal to y double dash plus a1 of x into y dash plus a2 of x into y, which is equal to 0 on an interval I. On an interval I, and phi 1 of x is not equal to 0 on I1 I, then the second solution, the second solution phi 2 of x is given by, look at here, phi 2 of x is equal to phi 1 of x into integration x naught to x 1 upon into the bracket phi 1 of s bracket square into exponential of, exponential means e raised to power, okay, exponential of into bracket minus integration x naught to x a1 of t into dt, the whole bracket into ds. Okay, so this is the second solution of this given differential equation if phi 1 is known and phi 1 is not equal to 0 on an interval I. Okay, so this is the theorem we have to prove. Okay, any doubt in this theorem? Statement मध्ये काही doubt आहे का? If phi 1 is the solution of L of y, which is second order homogeneous equation with variable coefficients on an interval I, if phi 1 is not equal to 0 on I interval, then the second solution phi 2 of x is given by this one. Okay, this exponential, it means e raised to the power, हा तुमचा काय ब्रॅकेट म्हणजे power of e. Okay, any doubt in this theorem statement?
No, sir.
Now look at the proof. Let phi 1 be the solution of L of y. Let phi 1 be solution of L of y is equal to y double dash plus a1 of x into y dash plus a2 of x into y, which is equal to 0. Okay, on an interval I. Give it as an equation number 1. So it implies if phi 1 is the solution of L of y, it means that L of phi 1, which is equal to 0. That is phi 1 double dash. It satisfies this equation. Okay. Second order homogeneous equation. Phi 1 double dash plus a1 of x into y1 dash plus a2 of x into phi1, which is equal to 0. Give it and is equation number 2. Okay, now let phi2 of x, phi2 of x is equal to u of x into phi1 of x be second solution, second solution of equation 1, where the function u is to be determined, to be determined. आपल्याला काय फाइंड करायचं आहे, u of x हा फंक्शन काय तो डिफाइन करायचा. Okay, then if phi 2 is the solution of L of y, then we have L of phi 2 is equal to what? 0. That is L of u into phi 1, which is equal to 0. Okay, any doubt up to here? Which implies in the bracket, if u into phi 1 is equal to 0, so this u into phi 1 satisfies the second order homogeneous equation, which is u into phi 1 double dash plus a1 of x into bracket u into phi 1 dash, okay, bracket dash, plus a2 of x into u into phi 1, which is equal to 0. Okay, काही डाऊट आहेत का इथपर्यंत? Any doubt?
No, sir.
Okay. Now, differentiate with respect to x double dash. Directly second step. So here we get u double dash into phi 1 plus 2u dash into phi 1 dash plus u phi 1 double dash. Okay. Plus a1 of x into first as it is derivative of phi 1 plus say first second as it is phi 1 into u1, sorry, u dash. Okay, so this is u dash into plus a2 of x into u into phi 1, which is equal to 0. Okay, any doubt up to here? Any doubt up to here? Now, the collecting the terms coefficients of u1, which implies take u common from this one, this one, this one, and this one. So here we get u of x into phi 1 double dash plus a1 of x into phi 1 dash plus a2 of x into phi 1 plus u double dash into phi 1 plus 2 u dash into phi 1 dash. This term is as it is. Okay. Plus a1 of x, remaining terms, light, remaining terms. Okay. Phi 1 u dash is equal to 0. Okay. Any doubt up to here?
No, sir.
No, sir.
Okay. It implies this is what? U into L of phi 1 plus u double dash phi 1 plus 2 into u dash into phi 1 dash plus a1 of x into phi 1 u dash, which is equal to 0. But L of phi 1 is what? What is the value of this one is 0. So 0 plus u double dash into phi 1 plus 2 u dash into phi 1 dash plus a1 of x into phi 1 into u dash, which is equal to 0. Okay, from 2. So this gives, which implies that u double dash into phi 1 plus into this bracket 2 phi 1 dash plus a1 of x into phi 1 into bracket u dash, which is equal to 0. Okay. Now, if, look at here, if v is equal to u dash, put v is equal to u dash is equal to v, then above equation reduces to a linear differential equation of order of order 1
First
or 2?
order.
1. Okay, which implies v dash u double dash is nothing but v dash into phi 1 plus 2 into v, sorry, 2 into phi 1 dash plus a1 of x into phi 1 into v, which is equal to 0. Okay, so rearrange the terms. We get v dash upon v dash of x upon v of x plus 2 into the bracket phi 1 dash of x upon phi 1 of x plus a1 of x. Okay, which is equal to 0. कळते का? Divide और काय करायचं, divide this equation by v of x into phi 1 of x. So we get this equation. Okay, rearrange केलाय फक्त तो. का करून दाखवू दे?
No, sir.
गरज नाही ना? ओके, काही गरज नाही ना दाखवण्याची?
No, sir.
हा, rearrange करा फक्त terms, which implies v dash of x upon v of x, okay, plus 2 into phi 1 dash of x upon phi 1 of x, which is equal to minus a1 of x. Now integrating above equation from x naught to x, where x naught is the point in between interval I. Okay, integrating above equation from x naught to x. Okay, where x naught is the point in between interval I. So here we get x naught to x v dash of x upon v of x into dx plus 2 into bracket x naught to x phi 1 dash of x upon phi 1 of x into dx, which is equal to minus a1 of x integration x naught to x into dx. Okay, or we can take here t dt. Okay, variable change करा. ओके, इथे टी घेऊन व्हेरिएबल चेंज करा v dash of t, कारण की का इथे आपण इंटिग्रेशन काय घेतलंय, here we take integration x naught to x. At the end we get the function of x again. Okay, this is t. So here we get, what is the integration of this one?
Log of v of t.
Log of v of t, lower limit is x naught and x plus 2 into what is the limit of this one?
Log of phi 1 of t.
Log of phi 1 of
Phi 1 of t at lower limit x naught, and this is x, and this one is as it is x naught to x a1 of t into dt. Okay, so here we get, which implies log of v of x minus log of v of x naught plus 2 into bracket log of phi1 of x minus log of phi1 of x naught, okay, which is equal to minus x naught to x. This term is as it is, okay, which implies log of v of x upon v of x naught plus log of y1 of x upon y1 of x naught, which is equal to minus integration x naught to x a1 of t dt, okay, which implies log of v of x into phi1 of x upon v of x naught into phi1 of x naught, which is equal to minus integration x naught to x into a1 of t dt. Okay, any doubt up to here?
सर तिथं टू राहिलंय.
Okay,
Good.
this one is काय होणार आहे हा तुमचा, wait a minute, हा तुमचा phi1 स्क्वेअर, सॉरी, ओके. आता हा तिथं मल्टिप्लाय केल्यानंतर काय होणार, हा वर जाईल ना. ओके, आता काही डाऊट आहे?
No, sir.
Now this implies v of x into phi1 square of x upon v of x naught into phi1 square of x naught, which is equal to exponential of, okay, e raised to power minus integration x naught to x a1 of t into dt. Okay, any doubt up to here? But x naught and x is the particular point in between what? X naught is the point in the interval I. So here we get put v of x naught into phi1 square of x naught. हा काय येईल तुमचा एक कॉन्स्टंट आहे, ओके, which is equal to c. So here we get v of x into y1 square of x upon c, which is equal to exponential of minus integration of x naught to x a1 of t dt. Okay, any doubt? काही डाऊट आहेत का?
No, sir.
No, sir.
काही डाऊट्स आहेत का? हा विचारू शकता.
No, sir.
Okay, which implies v of x into y1 square of x is equal to c into exponential of minus x naught to x a1 of t dt. Okay, so this one is, which implies, but we know that phi1 of x is not equal to 0 on I. Hence, we can divide phi1 of x to the whole equation. So here we get phi1 of v of x is equal to c upon phi1 square of x into exponential of minus x naught to x integration a1 of t dt. Okay, but what is v of x? V of x is nothing but what? U dash of x. Okay, which is equal to c into phi1 square of x into exponential of minus x naught to x a1 of t dt. Okay, now again integrating from x naught to x, integrate from x naught to x, we get here u of x, which is equal to integration x naught to x c upon the variable change करायचं phi 1 of phi 1 square of yes घ्या. Okay, so exponential of this term is as it is x naught to x a1 of t dt आणि इथं काय येईल इंटू इथं काय व्हेरिएबल एस आहे ना, मग इथं काय येईल ds. ओके, एनी डाऊट?
No, sir.
This is the u of x. U of x is equal to, take c common, c into integration x naught to x 1 upon phi 1 of s bracket square. Okay, this is nothing but this one. Exponential of minus x naught to x a1 of t, this dt into ds. Okay, but we have phi 2 of x is equal to u of x into phi 1 of x, which implies phi 2 of x is equal to, this is phi 1 of x as it is, and this is c into phi 1 of x into u of x, which is nothing but this one, x naught to x 1 upon phi 1 of s bracket square into exponential of x naught to x minus a1 of t dt into ds. Okay, any doubt? So this is the phi 2, is the proof. So using the phi 1 value, we can obtain phi 2. Okay, now we can neglect, हे आपण c neglect हे करू शकतो. Why? Look at here. If, okay, in the bracket, if c into phi 1 of x is the solution, it implies phi 1 is also solution. Okay, okay, scalar multiple of solution is solution. So take scalar 1 upon c. So here you get phi 1 is the solution. Hence it implies phi 2 of x is equal to phi 1 of x into x naught to x 1 upon integration x naught to x 1 upon phi 1 of s bracket square into exponential of minus x naught to x integration a1 of t dt into ds. Okay, so this is the proof of the theorem. Any doubt?
No, sir.
Okay, so using the phi 1, the solution phi 1, we can obtain the second solution of the homogeneous linear differential equation of order 2. Okay, now look at this example घेतल्यानंतर तुम्हाला क्लिअर होईल. Example number 1. Example number 1. A differential equation, and the function phi 1 and function phi 1 are given in each of the following, verify that the function phi 1 satisfies the equation and find a second solution second independent solution okay. For example, this one y double dash minus 4xy dash plus into bracket 4x square minus 2 into y, which is equal to 0. Okay, and we have phi 1 of x is equal to e raised to x square. So using this phi 1, we have to find phi 2, and we have to verify this phi 1 of x satisfies the given equation. Okay, given differential equation. Okay, any doubt? Now, given y double dash minus 4xy dash plus into bracket 4x square minus 2 into y, which is equal to 0. Give it as an equation number 1. Okay. Now consider, which is equal to L of y. Na? This is L of y. Now consider L of e raised to x square. Okay. That is L of phi 1 of x. L of phi 1 of x is equal to L of e raised to x square, which is equal to e raised to x square double dash minus 4 into x into put instead of y e raised to x square. So here we get 4 into x into in the bracket e raised to x square y dash plus 4x square minus 2 into e raised to x square. Okay, which implies सांगा next term काय होणार e raised to L of e raised to x square. सॉल्व करा आणि काय ते सांगा आन्सर शेवटी लास्ट आन्सर सांगा मला एकदम काय सॉल्व करते हैं ना सॉल्व करत असाल तर मी थांबतोय नाही तर मी लिहून तो पुढचं टर्म ओके करताय काय करू दे हॅलो
करतोय सर.
करते हा असं रिप्लाय करते ना म्हणजे मी थांबेन तरी सो वी हॅव दिस वन e raised to x square into 2x this is the first derivative minus 4x e raised to x square into 2x minus this is 4x square minus 2 into e raised to x square. Now the second derivative of this one. Okay. This one is as it is. E raised to x square. Derivative of this
2.
2 plus okay 2x as it is 2x into e raised to x square okay minus 4 so this is 8 4 into 8 x square into e raised to x square plus 4 x square into e raised to x square minus 2 into e raised to x square. Now this one solve करा है ये क्या ना 2 into derivative of this okay नहीं चला solve this one e raised to x square
0.
0 all 0 okay so here we get L of phi 1 of x is equal to 0 okay it implies that phi 1 of x is equal to e raised to x square is solution of 1 is solution of equation 1. Okay, any doubt up to here?
No, sir.
No, sir.
Now, to determine the second solution, second independent solution. Okay, let, wait a minute. Not of x, what is the not of x? Okay. To determine the second independent solution, let phi 2 of x is equal to u of x into phi 1 of x. Okay, so which is equal to u of x into e raised to x square. Okay, we have to find the value of u of x. So what is u of x? Where u of x by previous theorem. Okay, integration 1 upon phi 1 of x bracket square into exponential of the bracket minus of integration a1 of x into dx bracket dx. ओके, आता तुम्ही इथे म्हणताल यू ऑफ एक्स ला इथे एक्स नॉट टू एक्स का घेतलं नाही? ओके, का घेतलं नाही नीट लक्ष द्या. तुम्ही एक्स नॉट जर घेतला तर इथं काय येत होतं आपल्याला? सी येत होतं. ओके, सी ची व्हॅल्यू काय पुट केली आपण? लुक एट हियर, v of x into pi 1 square of x naught. जर आपण x naught घेतलाच नाही तर हे खालची टर्म्स येणारच नाही. ओके, लुक एट, जर इथे x naught to x आपण घेतलाच नाही इंटिग्रेशन तर इथे काय येईल? इथे x naught येणार नाही, इथे x naught येणार नाही. ओके, डायरेक्ट तुमचं काय इक्वेशन येईल? इथे खाली v of x naught आणि phi 1 square of x naught हा येणार नाही. म्हणजेच काय, तुमचा c येणार नाही. आपण शेवटी जाऊन काय केलंय? c निग्लेक्टच केलेलं आहे. ओके, c निग्लेक्टच केलेलं आहे. इफ c into phi 1 is the solution, then phi 1 is the solution. ते निग्लेक्ट केल्यामुळे आपण इथे इंटिग्रेशन घेतलं नाही, लिमिट घेतलेलं नाही. ओके, कळतंय का?
येस सर.
हो,
इथं
sir.
शेवटी आपल्याला ते निग्लेक्टच करायचं, त्यामुळे ते इंटिग्रेशनचं लिमिट घेतलेलं नाहीये. ओके, फाइंड द u of x. u of x is equal to integration 1 upon what is phi 1? E raised to x square. Okay, whole bracket square into exponential of bracket minus what is the a1? Look at here, the coefficient of y dash. What is the coefficient of y dash? Minus 4x. Okay, minus 4x into dx in the bracket, so in this case dx, which is equal to integration 1 upon e raised to 2x square. Okay, any doubt? Any doubt?
No, sir.
हेच मी कसं लिहू शकतो? e raised to minus 2x square. Any doubt?
No, sir.
Into exponential of, this is integration of 4x dx into dx, which is equal to integration of e raised to minus 2x square. So this is the हे काय तुमचं एक्सपोनेन्शियल आहे ना, e raised to power. Okay, what is the integration of 4x? 4 common, this is x square upon 2, so 2 2 is 4, 2x square. Okay, e raised to काय येणार इथे? x square, 2x square into dx. Okay, any doubt?
No, sir.
No, sir.
which is equal to integration of 1 dx, which is equal to x. So this is u of x. Now the required solution is, that is phi 2 of x is equal to what? U of x into phi 1 of x, which is equal to x into e raised to x square. Okay, so here we get phi 1 of x is equal to e raised to x square, and phi 2 of x is equal to what? X into e raised to x square. So these are the two solutions of given differential equation. Okay, second order homogeneous differential equation. Okay, now we have to prove that these two equations are linearly independent. Okay, now to prove that phi 1 and phi 2 are linearly independent. Now let C1 phi 1 of x plus C2 phi 2 of x is equal to 0. It implies C1 phi 1 is what? E raised to x square plus C2 x into e raised to x square, which is equal to 0. Differentiate with respect to x. So here we get, wait a minute. Sorry, e raised to x square is common. So here we get C1 plus C2 of x is equal to 0, which implies this is the always positive. So here we get C1 plus C2 of x must be 0. Now differentiate with respect to x, we get C2 is equal to 0. Now putting this value in this equation implies C1 is equal to 0. Okay, it implies that phi 1 and phi 2 are linearly independent solutions. Okay, any doubt? कसं सॉल्व करायचं कळालं एक्झाम्पल?
Yes, sir.
Okay, now solve for the homework. Second question. X square into y double dash minus 7xy dash plus 15y, which is equal to 0. This phi 1 of x is given to us, is equal to x cube for all x greater than 0. Third one, x square into y double dash x y double dash minus x plus 1 into y dash plus y, which is equal to 0. This phi 1 of x is e raised to x. X is greater than 0. Fifth one, 1 minus x square into y double dash minus 2xy dash plus 2y, which is equal to 0. Given phi 1 of x is given to us x. Okay, 0 is less than or equal to less than x. दिल नहीं है एकच मिनिट. Less than 1 असेल. Less than 1, correct. Sixth one, y double dash minus 2xy dash plus 2y, which is equal to 0, and the phi 1 of x is equal to x, and x is greater than 0. Okay, solve these 5 examples. ओके, शेवटचं घ्यायचं का आपण? शेवटचं एक सॉल्व करूया, सिक्स नंबर. ओके, हे सॉल्व करूया. Now here L of y given, L of y is equal to y double dash minus 2xy dash plus 2y, which is equal to 0, and phi1 of x is equal to x, where x greater than 0. Now, L of y is equal to y double dash minus 2xy dash plus 2y. Give it as an equation number 1. Okay. To prove that phi1 of x is equal to x is solution of 1. Consider L of phi1 is equal to phi1 double dash minus 2x phi dash plus 2 into phi, which is equal to L of x is equal to x double dash minus 2x into x dash plus 2 into x. So here we get काय येणार इथे
0
0,
minus 2x plus 2x.
which is equal to 0. So L of x is equal to 0. It implies L of phi1 is equal to 0. It implies phi1 of x is equal to x is solution of equation 1. Okay. Now let you have to find phi 2. Phi 2 of x is nothing but u of x into phi 1 of x, which is equal to u of x into x. Now to find u of x, u of x is equal to integration 1 upon phi 1 of yes, okay, bracket square into exponential of to bracket minus a1 of x dx into ds, which is equal to integration 1 upon x square into exponential of minus what is a1?
minus
What is A1?
2x.
Minus 2x. So here we get a1 is minus 2x dx into ds क्या 5 of s है ना इथे. So here ds किंवा x घेतलं तरी काय अडचण नाही. Phi 1 of x is x, so phi 1 of yes is yes. Integration 1 upon s square into this minus minus get plus. What is the integration of x? X square upon 2. 2 get cancelled. So here you get only e raised to x square. Okay, into ds. Wait a minute. x is घ्या. तर तुम्ही हे काय म्हणता variable x is x dx x square dx. This is x square into dx. जर s असेल तर काय करणार तुम्ही हे कॉमन घेणार बाहेर. ओके, कॉन्स्टंट समजून त्याला बाहेर काढणार इंटिग्रेशन. सो दिस इज u of x is equal to integration 1 upon x square into e raised to x square. कसं करणार त्याचं इंटिग्रेशन? Which is equal integration x raised to minus 2 into e raised to x square into dx. ओके, येईल का काढता? u into e रूल वापरा आणि काढा. ओके, so this is the u of x. So phi 2 of x is equal to, जर येत नसेल तरी असंच ठेवा, काय अडचण नाही. ओके, येत नसेल तरी असंच ठेवलं तरी काय अडचण नाही. phi 2 of x is equal to u of x into phi 1 of x, which is equal to x into integration x square, x raised to minus 2 into e raised to x square dx. Okay, so this is the phi 2 of x. Now to prove that phi 1 and phi 2 are linearly independent. So consider C1 phi 1 of x plus C2 phi 2 of x, which is equal to 0. Okay, which implies C1 of x plus C2 of x into e raised to x square into x raised to minus 2 dx is equal to 0. Since x is greater than 0, dividing above equation by x, we get c1 plus c2 integration e raised to x square into x raised to minus 2 dx is equal to 0. Okay, so differentiate with respect to x, we get c2 into e raised to minus e raised to x square into x raised to minus 2, which is equal to 0. But this is never 0 because x is greater than 0 and e raised to x is positive function always. Hence, c2 must be 0, which implies putting the values of c2 in this equation, where we get c1 is also 0. Hence, phi 1 and phi 2 are linearly independent. Okay, any doubt?
No, sir.
समजते? बाकीचे 4 एक्झाम्पल सॉल्व्ह करा असेच. जर इंटिग्रेशन नाही आलं तर तुम्ही फाय टू तेच यू तेच ठेवू शकता. ओके, येत नसेल तर. Now, the next point of our syllabus is theorem is there. Okay, हा theorem जरा खूप किचकट आहे. किचकट म्हणण्यापेक्षा लेंदी आहे थोडा. Okay, so next theorem. ओके, इथपर्यंत काही डाऊट आहे का कोणाला?
No, sir.
No, sir.
ओके, वेट अ मिनिट. ओके, फक्त कॅल्क्युलेशन करताना चुकू नका म्हणजे झालं. ओके, फक्त यात सगळे कॅल्क्युलेशनच आहे, असं कन्सेप्च्युअल लेवलचे कोणतेही थेरम नाही ते. ओके, सो द नेक्स्ट थेरम इज let phi 1 be a solution of L of y is equal to 0. Okay, that is L of y is equal to y raised to n plus a1 of x into y raised to n minus 1 plus a2 of x into y raised to n minus 2 up to so on an of x into y, which is equal to 0. Okay, so phi 1 is the solution of this equation on an interval I. On an interval I, then we can reduce the order, then we can reduce the order of equation L of y is equal to 0 by 1. if okay, if v wait, v2 v3 up to so on vn are linearly independent solutions of the reduced differential equation of order n minus 1 and vk is nothing but uk dash. Okay, uk dash for k running from 2 3 u1 phi1 u2 phi2 up to so on. Wait, it's not phi1, u1 phi1 u2 phi1 up to so on un phi1, okay, are linearly independent solution of L of y is equal to 0 on I. Okay, this is the statement of the our theorem. Let phi 1 be the known solution of L of y is equal to 0. What is the L of y? The nth order homogeneous differential equation with variable coefficient. Okay, if phi 1 and these are the solutions of L of y is equal to 0. These are the n solutions. Phi 1 is nothing. Wait a minute. किती सोल्यूशन झाली फाय वन u1 फाय वन u2 फाय वन हे n प्लस वन सोल्यूशन झाले ना सो दिस इज नॉट ओके आता येईल तुमचा फाय वन फाय वन and u2 फाय वन okay u1 phi 1 is nothing but phi 1. If phi 1 is the solution of L of y, what is the L of y? Nth order homogeneous linear differential equation with variable coefficient on an interval and I, then we can reduce the order of homogeneous equation. The order of that given equation L of y is equal to 0 by 1. Okay, मग जर इक्वेशन ऑर्डर आपण जर रिड्यूस केली if we reduce the order of that equation then the new equation of order n minus 1 and that v2 v3 up to vn, these n minus 1s are the solutions of reduced differential equation which are linearly independent. Okay, and what is the relation between uk and vk? Is nothing but vk is equal to uk dash. Okay, for k running from 2 to 3 and the phi 1 u2 phi 1 up to so on v and phi 1 are the linearly independent solution of L of y is equal to 0 on an interval I. Okay, काही समजतंय का? ओके
Yes, sir.
हा काही अडचण असेल तर विचारू शकता.
सर V1 यू का नाही घ्यायचं V1 किंवा K इज इक्वल टू 1 2 3 असं 2 पासून का घ्यायचं?
2 पासून का घेतलंय? आपण काय
हम्म.
केलंय तर वी कॅन रिड्यूस द ऑर्डर ऑफ इक्वेशन बाय 1 ना. इक्वेशन जर 1 केली तर nth ऑर्डरची इक्वेशन आहे तुमची. ओके, मग nth ऑर्डरची
ओके.
इक्वेशन रिड्यूस 1 केल्यानंतर काय येणार मग y रेस टू n मायनस 1 येणार. ओके, मग n इक्वेशन जर n मायनस 1 ऑर्डरची असेल तर त्याला रूट्स किती असतात? सोल्युशन किती असतात? जेवढी त्याची ऑर्डर आहे. म्हणून इथे v2 टू vn. ओके, and
हा.
what is the relation between v2 and हा विचारा.
नाही झालं.
Okay, what is the relation between vk and uk? vk is equal to uk dash. k रनिंग कुठून होते? 2 पासून रनिंग होते. Okay, now look at the proof. खूप लेंदी आहे, 3 ते 4 पानाचा थेरम आहे. सो नीट लक्ष द्या मी काय सांगतो व्यवस्थित आणि लिहून घेत चला ते तसंच. लेट phi1 be solution of L of y is equal to 0. That is L of y is equal to y raised to n plus a1 of x into y raised to n minus 1 plus up to so on an of x into y, which is equal to 0. Okay, we try to find a solution phi of L of y is equal to 0. We try to find a solution phi of L of y is equal to 0 of the form phi is equal to u of x into phi 1 of x. Okay, now look at here where u of x is n times differentiable function defined on interval I. Okay, any doubt up to here?
No, sir.
Now, if phi of x is equal to, what is phi of x? U of x into phi 1 of x is the solution of L of y is equal to 0, is the solution of L of y is equal to 0, then L of phi of x is equal to 0, which implies L of u of x into phi 1 of x, which is equal to 0. Okay, now put u of x into phi 1 of x in this nth order equation. So here we get, it implies that, neat laksh द्या, u phi 1. Okay, instead of u of x and phi of x, we can write only u phi 1 bracket raised to nth derivative plus a1, okay, a1 of x into u into phi 1 into u into phi 1 bracket raised to n minus 2 up to so on plus an of x into u phi 1 look at bracket dash म्हणजे the n minus 1th okay, the n minus 1th coefficient of x plus now here an of x into u into phi 1, which is equal to 0. Okay, any doubt up to here? n minus 1, okay, n minus 1 is there. Nth minus 1th coefficient. Okay, any doubt?
No, sir.
No, sir.
Now, by Leibniz rule, Leibniz rule of differentiation, okay, what is the Leibniz rule? If u into v bracket raised to n हा डेरिव्हेटिव्ह असेल तर आपण ह्याचं कसं सॉल्व्ह करतो? u raised to n into v plus n times u raised to nth minus 1 derivative of u into v1 v dash plus n into n minus 1 upon
2
2 factorial into u raised to nth minus second derivative n minus 2 into
v double
double dash, okay, plus up to so on n into u dash into v raised to n minus 1. या दोघांची ऍडिशन येण्या पाहिजे इथे nth डेरिव्हेटिव्ह इथे 0th डेरिव्हेटिव्ह इथे 1 nth मायनस 1 आहे इथे 1 आहे तर दोघांची ऍडिशन किती येते n येते इथे किती येते दोघांची ऍडिशन n येते सो हियर u रेस टू 1 v रेस टू n minus 1 plus u as it is and v raised to what
n
n. Okay, so this is the Leibniz rule of differentiation. Okay, आता u into 5 ला हा रूल वापरायचा आहे ब्रॅकेट रेस टू n. ओके, u into 5 रेस टू ब्रॅकेट रेस टू n ला पुन्हा u into v ह्याचा रूल वापरायचा तेव्हा इथे काही n minus होईल. ओके, प्रत्येक टर्मला तुम्हाला काय वापरायचं आहे लेबनिट्झ रूल ऑफ डिफरन्शिएशन म्हणून नीट लक्ष द्या नंतर. ओके, फॉर फर्स्ट टर्म काय तुमची u into 5 रेस टू n तर त्यासाठी काय ना नीट लक्ष द्या u रेस टू n into 5 plus n into u रेस टू nth minus 1 into 5 dash plus n into n minus 1 upon 2 into u raised to n minus 2 into 5 double dash plus up to so on plus n into u dash into 5 raised to n minus 1 plus u into 5 raised to n. ओके, ही पहिल्या टर्मची झाली तुमची प्लस दुसरा टर्म काय येणार इथं a1 of x आहे तसंच येणार कॉमन. ओके, इंटू ब्रॅकेट आता इन्स्टेड ऑफ n इथं काय येणार n minus 1 येणार. ओके, सो इथं काय येणार n minus 1 येणार. ओके, करस्पॉन्डिंग चेंजेस होत जाणार. ओके, नाउ लुक एट हियर a1 of x into bracket u raised to n minus 1 into 5 plus instead of n काय येणार इथे आता n minus 1 येणार. ओके, u raised to n minus 2
2 5 1 dash
5 dash plus instead of n काय येणार n minus 1 instead of n minus 1 काय येणार
n minus 2
n minus 2 upon 2
3
factorial
factorial
u raised to n minus 3 येणार into 5 double dash. Okay, plus up to so on plus n minus 1 into u1 u raised to 1 into 5 raised to n minus 2 plus u into 5 raised to n minus 1. ओके, हे सेकंड टर्मची झाली तुमची लेबनिट्झ रूल. ओके, नाउ सिमिलरली फॉर a2x याच्याच पुढे आहेत बघ का ते प्लस a2 of x into इन्स्टेड ऑफ आता येते n minus 1 च्या ठिकाणी काय येणार n minus 2
2
into 5 plus n minus 1 च्या ठिकाणी n minus 2 येणार आता into u raised to n minus
3
to 5 dash plus n minus 2 into n minus 3 upon 2 factorial. Okay, into u raised to n minus 4 into 1 double dash. ओके, दोघांची ऍडिशन n minus 2 यायला पाहिजे प्लस अप टू सो ऑन प्लस इथे काय येणार n minus 1 च्या ठिकाणी n minus 2
2
u dash into 5 n raised n minus
minus
3.
3
Okay, into u into phi 1 raised to n minus 2. Okay, ही झाली तुमची सेकंड टर्म. थर्ड टर्म प्लस अप टू सो ऑन प्लस an of x. ओके, आता इथे काय ना काय n of x ची टर्म काय u into phi 1. ओके, सॉरी an minus 1 ची टर्म ही टर्म. ओके, या टर्मसाठी काय येणार n minus 1 of x into bracket u into phi 1
dash
dash
5 1
u1 dash u dash into phi 1.
5 1
Okay, plus an of x into u phi 1 as it is, which is equal to 0. कोणाला काही डाऊट आहे का याच्यामध्ये? ओके, कॅल्क्युलेशन थोडं हार्ड आहे पण इझी. सॉरी, लेंदी आहे पण इझी. ओके, now the coefficient of u in the above expression, taking the coefficient of u in the above expression, the coefficient of u in the above expression. Okay, what is the coefficient of u expression is? Look at it. इथे काय येणार coefficient of u phi 1 raised to n. ओके, इथे काय येणार phi 1 raised to n minus 1, phi 1 raised to n minus 2. ओके, इंटू काय आहे हा काय तुमचा phi 1 raised to n plus a1 of x into phi 1 of n raised to phi 1 raised to n minus 1. This is the coefficient of u. So collecting this all this term. Okay, so here we get phi 1 raised to n plus a1 of x into phi 1 raised to n minus 1 plus a2 of phi 1 raised to n minus 2 up to so on an of x, an of x into phi,
5 1
sorry phi 1, which is equal to L of phi 1, which is equal to 0. Okay, now the right hand side, right hand side of the above equation, the above equation consists u1 dash, sorry u dash, u double dash, u triple dash up to so on u raised to nth derivative. Okay, now collecting the coefficients of u raised to n, u raised to n minus 1 up to so on u dash. Okay, so here we get u raised to n, nth derivative of u into phi 1. Okay, look at here. तुमचा काय आला कोएफिशिएंट ऑफ u raised to n. ह्याच्यानंतर u raised to n तुमचे कुठेही नाही आहे टर्म. ओके, u raised to n minus 1 ची कोएफिशिएंट काय येतील n into phi 1 dash, ओके, into a1 of x into phi 1. ओके, हे तुमचे कोणाचे कोएफिशिएंट येतील u raised to n minus 1 चे प्लस u raised to n minus 1th derivative into bracket n into phi 1 plus a1 of x into phi 1. Okay, any doubt? u raised to n minus 1 चे कोएफिशिएंट काय तिथे n into phi 1 dash plus a1 of x into phi 1 of x. Okay, हेच दिले प्लस u raised to n minus 2 याचे काय येतील कोएफिशिएंट्स n into n minus 1 upon 2 factorial. Okay, याचे कोएफिशिएंट काय येतील u raised to n हा एक कोएफिशिएंट येईल into काय ना a2 of x into phi 1. Okay, wait a minute, u raised to n minus 2 is na, हाँ correct. Okay, any doubt? Proceed. Upon this one. Okay, wait a minute. Plus काय येईल पुढे एकच मिनिट थांबा u raised to n minus 1 ना u raised to n minus 1 चे इथे कोएफिशिएंट आहे a1 of x into n minus 1. ओके, phi 1 dash इथे तुमचा कोएफिशिएंट काय येईल u raised to n minus 2 चा हा इथे काय येणार n minus 1 a1 of x आणि phi 1. ओके, प्लस a1 of x into n minus 1 phi 1 dash plus u dash याचा कोएफिशिएंट काय येईल n into phi 1 raised to n minus 1 plus a1 of x into n minus 1 into phi 1 raised to n minus 2 plus a2 of x into n minus 2 into phi 1 raised to n minus 3. Okay, up to so on an minus 1 of x into phi 1 which is equal to 0. Okay, कळते का फक्त u raised to n u raised to n minus 1 u raised to n minus 2 चे कोएफिशिएंट सेपरेट घेतले कॉमन घेतले. ओके, एनी डाउट रिप्लाय द्या
सर
काहीतरी. हां
u raised to n minus 1 आहे ना तिथे n into phi 1 dash येते
phi 1 डॅश आहे का एकच मिनिट
हो सर.
आणि
हां
इथे पुढे पण phi 1 डबल डॅश राहील
कुठे
u raised to n minus 2 त्या ब्रॅकेट
हां
मध्ये
इथे
इथे
a1
पुढे पण
n into
इथे
n minus 1 upon 2
नाही
factorial. Second bracket.
into n minus 1 upon 2 factorial तिथे
हां
हाँ.
phi 1 डबल डॅश. ओके, phi 1 डबल डॅश प्लस हां आता काही आहे का डाऊट.
No,
Okay, now since v of x is equal to u dash of x, that is v is equal to what u dash. So here we get it implies u raised to n minus 1 काय येणार v raised to n minus 1 into phi 1 plus u raised to n minus 2 काय येणार v raised to n minus 2 into okay n into phi 1 dash plus a1 of x into phi 1 plus v raised to n minus 3. ओके, ब्रॅकेट लिहिते पुन्हा आहे तसंच सगळं. ओके, ब्रॅकेट आहे तसंच लिहा अप टू सो ऑन at the last v u dash is equal to काय ना v into हा सगळं ब्रॅकेट आहे तसंच येणार which is equal to 0. Okay, since phi 1 of x is not equal to 0, since phi 1 of x is not equal to 0 on I. Okay, दिले का कंडिशन त्यांनी हां दिले थेरममध्ये दिले लुक ॲट इफ घेतलं नाही का थेरममध्ये on an interval I and phi 1 of x is not equal to 0 on I aside. Okay, hence we divide the equation by phi 1 of x. Okay, we can divide the above equation by phi 1 of x. We can divide the equation above equation by phi 1 of x. Okay, thus we can reduce the order of differential equation to n minus 1. Okay, so this is the equation, differential equation with order n minus 1. Okay, now suppose v2, v3 up to so on vn be the linear independent solutions of the differential equation in V of order n minus 1, then we have Vk is equal to, wait a minute, Vk is equal to phi 1. एकच मिनिट equal to v1 is equal to vk is equal to phi 1 दिले तुम्ही okay look at this is v2 v3 vn be the linearly independent solution of the differential equation in V of order n minus 1. Okay, so we have Vk raised to n minus 1 into phi 1. V is equal to Vk is equal to phi 1 घेतलं स्टेटमेंट मी नंतर सांगतो फक्त Vk कसं आलं. ओके, आता एवढंच लक्षात ठेवा. Vk raised to n minus 1 into phi 1 plus Vk raised to n minus 2 into bracket n into phi 1 dash plus n minus 1 into phi 1 plus Vk raised to n minus 3 into bracket into phi 1 dash plus a2 of x into phi 1. Okay, plus up to so on plus Vk is equal to n into phi 1 raised to n minus 1 plus a1 of x into n minus 1 y1 raised to n minus 2 plus up to so on plus, okay, an of x into phi 1 which is equal to 0. Okay, wait a minute. V is equal to V के कैसे ठेवले? V1 is equal to phi 1 असेल. ओके, हे V के कसं आलं हे सांगतोय नंतर उद्याच्या स्टेपला. ओके, उद्याच्या लेक्चरला सांगू. Okay, so this is the equation of, this is the differential equation of with n minus 1 with degree n minus 1. Now we have vk of x is equal to uk dash of x. Okay, then it implies uk of x is equal to integration x naught to x vk of x dx. Okay, for k running from 2 to n, 2 to n. So here the uk of x is equal to integration x naught to x vk of t dt x to t. Then by assumption, then by assumption we have uk of x into phi 1 of x are solutions of what? Solution of L of y is equal to 0. Okay, thus the functions phi 1 u2 phi 1 u3 phi 1 up to so on un phi 1 are solutions of L of y is equal to 0. We are assumed this one. Okay, हाँ, तर काय order n minus 1, then तुमचा v1 म्हणजे काय येईल तुमचा phi 1 येईल. ओके, v1 म्हणजे काय येईल तुमचा phi 1. So here the phi 1 u2 phi 1, okay, sorry, स्टेप उद्या सांगतो मी तुम्हाला. ओके, फक्त एवढं लक्षात ठेवा. By assumption, uk of x into phi 1 of x are the solution of L of y is equal to 0. It implies phi 1, u2 phi 1, u3 phi 1, and up to vn phi 1. These are the n solutions, are the solutions of L of y is equal to 0. Okay, now to prove that, phi 1 u2 phi 1 up to so on un phi 1 are linearly independent. We have to prove that these solutions are linearly independent solution. Okay, such that suppose, well, we have to prove the solution are linearly independent. Suppose there are constant c1 c2 up to so on cn such that c1 phi 1 of x plus c2 u2 phi 2 of x plus c3 u3 phi 3 of x plus up to so on, sorry, phi 1, Cn un into phi 1, which is equal to 0. Since phi 1 of x is not equal to 0 on I, so dividing the equation, above equation by phi 1 of x, we get C1 plus C2 U2 plus C3 U3 plus up to so on, Cn Un is equal to 0. Now differentiate with respect to x. Differentiate with respect to x. We get, it implies C2 U2 dash plus C3 U3 dash plus up to so on, Cn Un dash of x is equal to 0. Okay, but uk dash is equal to what? Vk. For k running from 2 to n, it implies c2 into vk plus
V2.
wait v2 and okay v2 c3 into v3 plus up to so on cn into vn, which is equal to 0. Okay, but we know that in the given statement v2, v3 up to so on vn are linearly independent on I. Okay, it implies C2 is equal to C3 is equal to up to so on, which is equal to Cn, which is equal to 0. Hence, equation from equation star. What is the equation star? Here, this is the equation star. Putting the values of all C2, C up to Cn, we get C1 also 0. Hence, it implies that phi 1, okay, u2 phi 1, u3 phi 1 up to so on, un phi 1 are linearly independent solutions. Okay, any doubt?
No, sir.
फक्त त्यांनी इथे व्हीके कसं लिहिलं हे जरा समजत नाही, हे उद्याच्या लेक्चरला सांगतो. ओके, या स्टेटमेंटवरून, या इक्वेशनवरून कुठले, हां, ह्या इक्वेशनवरून हे इक्वेशन कसं लिहिलं हे समजत नाही. ओके, instead of v the v के replace केले त्यांनी. Okay, suppose we are linearly independent solution and v of order n minus 1 n minus 9, then we will see. Okay, any doubt up to here? याच्यात काय समजलं नाही सर, काय आहे का? Okay, okay, so we have proved that this statement, if phi is the phi 1 be the solution of L of y, then on an interval I, then we can reduce the order of equation L of y is equal to 0 by 1 if v2, v3 up to vn are the linearly independent solution of the reduced differential equation of order n minus 1 and vk is equal to uk dash. Okay, what is the relation between uk and vk? Vk is equal to uk dash for k running from 2 to n. Then all these n solutions are linearly independent. Okay, okay, any doubt? काही डाऊट असेल तर विचारू शकता. थोडं लेंदी आहे, पण कॅल्क्युलेशन पार्ट असल्यामुळे 2-3दा सराव करावा लागेल तुम्हाला. ओके, एक्झाम्पल घ्यायचं, एक्झाम्पल घेतल्यानंतर कळेल. ओके, लुक ॲट द एक्झाम्पल. This one is the example. One solution, example number 1. 6xy dash minus 6y is equal to 0 for x greater than 0 is phi1 of x is equal to x. हे तुमचं एक सोल्युशन दिलेलं आहे. ओके, फाइंड remaining how many solution?
2.
2.
Remaining two linearly independent solutions for x greater than 0. Okay, look at the given. What is the given equation? X cube into y triple dash minus 3x square y double dash plus 6xy dash minus 6y is equal to 0. Give it as an equation number 1. Let phi is equal to u into phi1. Okay, B, solution of equation 1, that is phi of x is equal to u into what is phi 1? X. Okay, phi 1 दिले ना तुम्हाला x. What is phi dash of x? First as it is, derivative of second is 1 plus second as it is, derivative of first. Okay, so this is phi dash. What is phi double dash of x? U dash as it is, this one. First as it is, derivative of second is 1 plus second as it is, derivative of first, u double dash. So here we get which is equal to 2u dash plus u double dash into x. Okay, what is the phi triple dash of x? सॉल्व करा काय तर u dash double dash plus derivative of this one x as it is plus u double dash into 1. So here we get 3 u double dash plus u triple dash into x. So this is y triple dash of x. Now the putting the all the values in equation 1. So equation 1 becomes x cube into phi triple dash means 3 u double dash plus u triple dash into x minus 3x square. ओके, तुमचं इथं काय आहे y ट्रिपल डॅश आहे ना, y ट्रिपल डॅश ऐवजी काय ठेवायचं आहे आपल्याला दिस वन minus 3x square into 2u dash plus u double dash of x plus 6x into u plus u dash of x minus 6x into u to 0. Solve this one. This is 3x cube u double dash plus x raised to 4 u minus 6x square u dash minus 3x cube u double dash, okay, plus 6x cube plus 6x square u dash minus 6xu is equal to 0. This plus gets minus gets cancelled. Okay. पुढे काय येणार? This 3. Wait a minute. Solve करा बघा काय येतं.
x raised to 4 u triple dash equals to 0.
ओके, सगळं कॅन्सल होतं ना.
Yes, sir.
इथे काय तुमचं यू डॅश वेट मिनिट
हो सर.
यू डॅश येतं नाही तर हा पण टर्म कॅन्सल होतो. ओके. So here we get x raised to 4 into u triple dash is equal to 0. Since x is greater than 0, it implies u triple dash is equal to 0. Now tell me what is the value of u. Integrate this one. First integrating we get implies. Again integrate केला क्या ना c1 okay. Now क्या c1x into c2. Again integrate c1x square plus c2x plus c3. Okay, here's it na?
Yes,
Yes
sir.
sir.
Okay, so this is the value of u. Now wait a minute. Okay, this is the value of u. Okay, now wait. Phi is equal to xu. What is the phi? X into u. Okay, but phi of x is equal to what? X into ux. So phi of x is equal to what? C1 x cube plus C2 x square plus C3 x. Okay, one solution is what? Phi 1 of x काय दिलेलं आहे तुम्हाला x आहे. Okay, phi 2 of x काय येणार मग
X square,
x square and phi 3 of x is
X cube.
x cube. So these are the solutions of given differential equation. Okay, x square आणि x cube हे तिन्ही कसे linearly independent solution आहे. Okay, any doubt?
No, sir.
So the next point is Ruskin and linearly independent. याच्या आधी बेसिस आहे तुमच्याकडे. ओके, लुक ॲट द डेफिनेशन ऑफ बेसिस. बेसिसचं डेफिनेशन बघूयात आणि थांबूयात. ओके, व्हॉट इज द बेसिस? इफ phi 1 phi 2 belongs to S, then C1 phi 1 plus C2 phi 2 this also belongs to S. Then the set yes it's called a linear space. Linear, that is vector space ना. लिनियर वेक्टर स्पेसला दुसरं नाव काय आहे? लिनियर स्पेस. ओके, लिनियर स्पेस ऑफ फंक्शन्स. Okay, linear space of functions. If a linear space yes, if a linear space yes contains n functions, n functions, phi 1 of x, phi 2 of x, up to so on phi n of x. Okay, suppose yes contains these phi 1, phi 2 up to so on phi n of x, which are linearly independent, which are linearly independent, and every function, every function from S can be represented by a linear combination of phi 1, phi 2 up to so on phi n, then the set yes. then the set, this set phi 1, phi 2 up to so on phi n. Okay, so this set is called basis ची डेफिनेशन दिली आहे तुम्हाला. Okay, it's called basis of linear space. Yes. Okay, as similar as vector space. These all these functions are what? Linearly independent functions, and any function belongs to yes. Okay, we can represented by the linear combination of phi 1, phi 2 of and phi n. Okay, then this set is called as basis, and the number of elements in the basis is called dimension of linear space. Vector space शिकलाय तुम्ही, शिकलायत ना?
हो सर.
Yes, sir.
हा, इथं काय घेतलंय फक्त तुमचं वेक्टर स्पेस म्हणजे काय घेतलंय? सेट ऑफ ऑल फंक्शन्स, लिनियर स्पॅन ऑफ एस घेतलंय तुमचं. ओके, लिनियर स्पॅन ऑफ फाय 1, फाय 2, फाय 3. ओके, समजा तुमचा हा जर सेट एस असेल, काय असेल? फाय 1, फाय 2 अप टू सो ऑन फाय एन. ओके, लिनियर स्पॅन ऑफ एस काय येणार? एल ऑफ एस कसं येणार? लिनियर स्पॅन ऑफ एस कसा लिहितो आपण? इज इक्वल टू a1 phi 1, a2 phi 2 up to so on plus an phi n such that all a's are तुमचं कोणतेही कॉन्स्टंट असतं. ओके, म्हणजेच काय, एखादा फंक्शन फाय तुम्ही जर लिनियर स्पॅन मध्ये घेत असताल तर तो फाय तुमचा फंक्शन कसा लिहितो? तुमचा a1 phi 1 up to so on an phi n for ai's. ओके, असंच आहे ना लिनियर स्पॅनची डेफिनेशन? हो की नाही?
हो
Yes, sir.
सर.
हो, sir.
द्या ना. जर आणि हे जर सगळे फंक्शन्स लिनियरली इंडिपेंडेंट असतील म्हणजे हा तुमचा सेट एस हा काय करतोय? सपोज दिस इज द वेक्टर स्पेस इज इक्वल टू लिनियर स्पॅन. हा तुमच्या वेक्टर स्पेसला काय करतोय? लिनियरली इंडिपेंडेंट पण आहे आणि तो स्पॅन पण करतोय, म्हणजे याला काय म्हणतो आपण? बेसिस. ओके, and the number of vectors in the set S, that is number of elements in the set S, is nothing but dimension. Okay, any doubt?
No sir.
Okay, in the next lecture we see what is the Roskian and linearly independent. Okay, पुन्हा तेच theorem, Roskian and linearly independent for the homogeneous differential equation of order n with variable coefficient. ओके, त्यानंतर आहे त्याचे 2-3 एक्झाम्पल्स असतात. ओके, त्यानंतर नॉन होमोजिनियस इक्वेशन आहे. ओके, एनी डाऊट इन दिस
No, sir.
लेक्चर? ओके, थांबायचं.
हो, sir.
Yes sir.
Thank you for attending the lecture. Now you can leave. Okay.
सर
हा, काय अडचण?
सर फर्स्ट चॅप्टरचे सर नोट्स द्या ना. त्या दिवशी तुमचा व्हिडिओ पॉज होता ना, मग ते राहिले सर.
वेट, जोरात बोला, तुमचा आवाज येत नाही.
सर फर्स्ट चॅप्टरच्या नोट्स.
फर्स्ट चॅप्टरचे नोट्स
हा द्या ना सर.